Hello folks, my name is Malik and welcome to my video channel. In this multi-part videos, our target is using Terragrunt as a thin wrapper to keep our codes dry and also create modules for using by Terragrunt. Let's start and continue our subject. In last session, we have created a VPC called VPC tutorial or tutorial VPC, and we defined this CIDR block 10.100.0.0/16. Now we have a plan to take a small slice of this big CIDR and assign it to our application and take another slice and assign to our DB groups. Why we want to do that? Our application works as a front end and database works as a back end. And customers interact with front end, not with back end. And we want to keep away database from the customers. So with this categorization, we improve the security of our database. This process called subnetting. So subnets are a way to slice up your VPC pie, where a VPC specify an IP address range. A subnet allows you to group these IPs into a smaller subnetwork. A subnet allows you to group those IPs into smaller subnetworks or subnet. This is great because you can then assign different behaviors to each of these subnets. So the main reasons for subnetting are deploy services into different AWS availability zones, which are different physical centers as we spoke in last session, and also improve the security of one of the subnets by hiding it from the internet. As you see here, we can create a subnet in one AZ and another subnet in another AZ. Also, we can create two subnet, three subnet in one AZ and another three subnet in another AZ. And let some of the subnet to be public. It means from the outside of AWS, these subnets are reachable. And if we put some of the subnet in private, nobody's from the outside can reach them directly. Let's back to VS Code. At first, let's change this one to tutorial VPC, and also let's Control X this one, remove that and add it after the provider. Okay, so in this section, create subnet. How to do that? Let's back to Mr. Google, search for this one, Terraform AWS subnet, and from the result, going here and take this code and put it in VS Code. Here, there is two keywords, VPC ID and CIDR block. VPC ID, it means from which VPC we should take this subnet. As I told you, imagine CIDR block is like a pie and you want to take one slice of that. So here we have to define from which VPC we want to take this subnet. Let's remove this one because this is default. Let's copy from here to end and put it here and remove this one and change to dot. I'm going to end. As you see, VPC ID, we should assign this VPC ID here. Just add .id here and it will assign when the Terraform run this command. At first, create a VPC. When VPC created, it will assign its ID to here. The second one is CIDR block. So we should change this one to be one slice of this CIDR block. So the whole of it is 10.100.0.0/16. So we take 56 IP of that as /24. Also, we can change this tag as subnet01, for example, and change this name to subnet1, for example. Save it. Let's run it. You see here, one resource will be added here. If we see here, the resource is a subnet, and the name of it is subnet01. Let's type yes and see what will happen. Let's back to AWS console. At first, you see the name changed to tutorial VPC, and going to subnet. Here, subnet01 has been created with this small CIDR block. There are other subnets here. They are belong to default CIDR block that we see here. Let's select this one, and recently AWS added resource map here. You can see it graphically. You see here in US is 1C. As I told you before, if we don't assign an availability zone to subnet, automatically AWS give a random AZ to this subnet. You see here subnet01 is here. There is a route table here, so leave it as is. I will speak about it a little bit later. Let's back to VS Code. In VS Code, we can assign availability zone. Let's back to Terraform documentation. Let's going down. You see here, there is availability zone item. Just we can copy this one and back to VS Code. Now here we can define this subnet will create to which availability zone. How to do that? If you remember, last time we have created an output to show us which availability zone are exist in US East 1. You see here the list of them as an output. We can take one of them manually, paste it here and run the code again, and we'll go at first delete the existing subnet from the US East 1C, and then we'll create a new one in US East 1A. Let's clean the terminal and apply. One new resource will be added and one will be destroyed. As I told you, at first it will go and destroy the last one. Yes, let's back to AWS console, refresh. If I select this one, in the resource map, it will show us in US East 1A. Let's back to VS Code. Let's copy this one and add another subnet here. As a subnet 2, for another subnet, use another range and add it in the same availability zone and call it 02. Save it and run. Let's back to console, refresh, select this one again from here. You see subnet 01, subnet 02, both of them in US East 1A. If you go to subnets, also here we can see them. Let's back to a picture that I showed you some minutes before. As you see here, I want to put my application in subnet 1 and my database in subnet B. As we spoke earlier, subnet A is as a front end. It means the customers from outside can reach it, but the second one, the customer from outside cannot reach it. So the first one is called public and the second one is called private. So let's back to our codes and make a little change here. Just change this name as a public subnet and the second one as a private subnet. Let's change the name here, public 01, Control C here, and private subnet 01. Just I change the tags. At the moment we know one subnet is public and another subnet is private. So the public one can have access directly to internet and the private one don't have direct access to internet. Let's apply or change. It's done. Let's back to console, resource map, and see private subnet 01 and public one. Let's go to subnets and we have both of them here. What's happened if this guy from outside wanna access to the public one? As you know, our tutorial VPC is inside AWS and it's locked and no one at the moment can access inside it. And also if we run an application inside that, this application cannot access outside to update its package or something like that. So what we should do to solve this problem and open this lock? So there is another concept that's called Internet Gateway. Internet Gateway open a way to public subnet can access internet directly. Or in another word, connect our VPC to the world of internet. How to add Internet Gateway? Let's back to Google. Let's search for this one. I'm going to the first link and just copy this code. So let's paste the code here. Number 5, create Internet Gateway. Like subnets, we need VPC ID. We can copy from here and put it here. And also we can tag it with Internet Gateway. Let's apply it. You see here, one resource will be add and type yes. Let's back to console, VPC, and going to Internet Gateway. You see this Internet Gateway is active. So we put this Internet Gateway here. Now we should tell this public subnet if want access to internet, how to do that. It means we should show route to outside. Now another concept comes to play. It's called route table. They allow you to define rules to say how traffic from public subnet going to internet. When we create a route table, we should associate that with subnet. Normally inside route table, we have two types of rules. Let's talk about two types of route table rules that we need to know about them. Number one is internal traffic, or also called local traffic. And the other one is external traffic. It means going towards internet. Imagine we have two applications inside public subnet. If they want to access each other in the same subnet, normally it is internal traffic. In the route table, we should define how they can communicate together. If you see here, this is our VPC CIDR block. So here we define if they are in this CIDR block, how to communicate internally. If the application need to access internet, we should define in route table if they want to go to internet, they should go through Internet Gateway. Normally for show outside word, we use 0000/0. It means to internet. So how we add route table in our codes? Let's back to Google. In Google, searching for Terraform AWS route table, from the first one, you see this code, resource AWS route table. Let's copy this one and back to VS Code. Number 6, create table. Resource route table. Let's give a name here, public route table. For the VPC ID, as the same we did before, we can copy from here and assign it to route table. This is for IPv6. Let's remove this one. Let's change the tag as also public, as a public route table. Okay, there is another block here. It's called route. This is the content inside route table. This one. Normally, when we create route table, automatically we'll create the first one. Just we need to add outside one. So for the gateway ID, we should take it from internet gateway. Let's back here, like the same that we did for VPC ID. Just we need to copy this one, Control C, put it here as a gateway dot ID. Here we should define, okay, you wanna go to where? We define here 0.0.0.0/0. We define if you wanna go to internet. We define here if you wanna go to internet. If you wanna go to internet, you should go through this internet gateway. Let's Control S. If you want to go to internet, you should go through this internet gateway. That's okay. So we created a route table. Now we should assign this route table to subnet. As I showed you in the picture, we should associate this route table to subnet. We should tell, hey, public subnet, this is the route. So we should add another item. It's called route table association. Let's back to Google, search for AWS route table association. From the first one, go inside and take this code back to VS Code number 7, create route association. Resource, AWS route table association. Give a name to it, public route association. Here we should define it should be associate to which subnet. We wanted to assign to the public one. Let's find the public one and take this one because we need to define subnet ID. Remove this one, Control V, as the same we did for VPC and for internet gateway. Just add ID. Now we associate the route table to subnet. Also for the route table ID, we should define the ID of the route table that we have created in last step. From here to here, just copy and put it here. Control S. Let's run this code. Yes. Let's back to console. Here, just refresh. Back to VPC. Let's show you in resource map. You see here, public subnet 1 connect to public route table and public route table connect to internet gateway. Also internet gateway going to internet. Now, if we put our application in subnet 01, this application can access to internet and also from internet can reach our application in subnet 01. Also, let's go to route table. This is the route table that we have created. Select it, and in the routes, you see automatically get local or internal routes, and we define if we want to go to internet, it should go through internet gateway. Until now, we have spoken about providers, about resources, a little about outputs, and I will speak more about it. Also with resources, I have created a network fundamental with a VPC, with internet gateway, subnets, public and private. So for the public, how can be connected to internet? We use a public route table and also use route table association for connect route table and subnets together. In continue, we'll speak if a database or an application in private subnet wanted to access internet, how should to do that? Because we don't want this subnet has internet direct access. If you are familiar with the network fundamental, in this situation, for access a private subnet to internet, for example, for update the packages, there is another concept called NAT gateway. NAT gateway has two legs. One leg sits in public side and access to internet, and another leg sits in private subnet. You know, NAT is abbreviation as Network Address Translator. I don't want to go deep inside how NAT it works, but in summary, translate private IP to public one. Normally, if NAT gateway want to work, need a public IP. All the private one that comes to NAT, for example, 10.103.10, for example, this IP, if comes to NAT, it should be a public IP here that can be translated to this public and go to internet. So for create a NAT gateway, we need to have a public IP. So as we spoke, NAT gateway should have a public IP. How we can reserve a public IP for NAT gateway in AWS? Let's back to Google. In Google, just we search Terraform AWS EIP, external IP, or elastic IP address. From the result, click on AWS EIP, and from here, just take this one and back to VS Code, just add it here. In the 8th step, we create elastic IP address. We can give a name to it. We don't need this one. Let's remove it and just finish this one. Let's save it. And also, we should add the code for create a NAT gateway. Let's back to Google. And from here, copy the NAT gateway. Back to VS Code. Number 9, create NAT gateway. Let's clean this one. Yes, the resource is AWS NAT gateway. Let's give it a name, NAT gateway. And also in tag, we can change it, for example, to NAT gateway 01. Save it. Here there is two keywords. We should fix them. Subnet ID. This NAT gateway should be associated with private subnet. So let's go to private subnet and copy this one and back here. Let's put it here and add ID at the end and remove this quotation with dot. Allocation ID, it should get from the EIP that we have created here. Also copy from here, Control C, put it here and just remove quotations. Also, there is another item, it's called depends on. It means this NAT gateway depend on internet gateway. It means at first we have to create internet gateway, and after that NAT gateway should be created. If we don't create internet gateway, we will get error. Here we should assign internet gateway details. Let's go up and find internet gateway, Control C, and back here and just copy paste here. No need ID because didn't ask for the ID, just this one. Control S and let's run this code. You see here, two resources will be added, one NAT gateway and one elastic IP. Here, type yes. It's done. Let's refresh here. And in the VPC page, let's select resource map. You see, NAT gateway 01 has been created. So what we need here? We need a private route table that can send traffic from the private subnet to NAT
gateway. So we need another route table. Let's back to VS Code. Just copy this one, Control C, put it here as a private and change this one as private. Here, for the public one, we told if you want to go to internet, you should go through internet gateway. But here, for the private one, we should define if gonna go to internet. Here, for the gateway, we should define NAT gateway. Let's copy the NAT gateway address, Control C, put it, remove quotation, replace with dot, and at the end add ID because need ID. It's almost done, but one is missing. As you remember, for the public one, we should create route association. Copy this one, put it here, and change it to private. Okay, for subnet, which subnet ID should be associated to the private, and replace here. And for the route table that we have created here, just copy this one and assign it here. Control S, let's save it and run the code again. Yes, 2 resources will be added. Yes, it's done. Let's back to console, refresh here. If we check this VPC resource map, you see here the private subnet will route through private route table and arrive to NAT gateway and go to internet, but the public one go to the internet through internet gateway. Let's finish the part 2 and we will continue soon. See you soon.